Alright, so now that we've done some algebra and we've got the big idea down, let's do a few more where we basically have to do a lot of that work. So again, starting with the cotangent plus tangent, is that equal to cosecant of x and secant of x? We're essentially having to maybe start with the worst side and make it into the other, or start with both sides. So how about we start with the summation first? So when I start with there, perhaps a trick to play is to just rewrite them in terms of their cosine and their sine. So let's see if that gets the trick done. And again, if after a few steps, if it's getting really messy and we can't see a light, we just start over. So let's see what happens here. So we're adding. So to add, I need a common denominator. So this needs a cosine of x, and this is missing a sine of x. So I think this is going to get us going. And so we end up with, over here, we end up with cosine squared x all over cosine x sine x, plus the second fraction is sine squared cosine x sine x. Alright, now that my denominator is the same, I can add, and we get cosine squared x plus sine squared x is all over cosine of x sine x. Of course, what do we know about cosine plus sine? That's 1. So we have 1 cosine x sine x. Well, 1 over cosine is secant, and 1 over sine is cosecant, and that's pretty much what that side is. It's, again, multiplication is reciprocal. So by rewriting in terms of sine and cosine using the quotient identity, adding by finding a common denominator, all right, using a Pythagorean identity, and then using a couple of reciprocal identities, we basically proved that this sum is equal to that product. So we got what we want. We're off to the races. Next problem. All right, and so in the next one, in my opinion, this subtraction seems to be the worst. And what we have is a 1 minus cosine and a 1 plus cosine. So let's go ahead and find a common denominator. It's basically this times that. So this fraction we need to multiply by 1 plus cosine. And so if I do that, I get 1 plus cosine of theta, 1 minus cosine of theta, right? Oops, minus. Here what we're missing is the 1 minus cosine. Okay, so the bottom is now the same, and it's also the difference of squares. The top, if we distribute, we have a sine theta plus cosine theta sine theta. We got to be careful here because not only are we distributing, but we also distributing a minus. So when I do that first round of multiplication, I have a minus sine theta cosine theta, and then a negative and negative. I have a plus sine theta cosine squared theta. Alright, so that's what I get after doing that first round of finding a common denominator, and then with that common denominator I can perform the subtraction, do the distribution all in one swoop. What I'm seeing here at this stage is I've got a cosine, sine, minus a sine, cosine, so that goes away. So upstairs, let me bring it up here, we have a sine of theta plus a sine of theta cosine squared theta all over 1 minus cosine squared theta. Alright, so we've got that all in the books. At this stage, what I'm seeing is we can factor out a sine theta, so there's our factoring going on, and we have a 1 plus cosine theta all over 1 minus cosine squared theta. So we're really close, right? Because one of the things I'm trying to get is a 1 plus cosine squared theta. So all that's missing is that cosecant. And so this tells me, despite all this hard work, I'm getting close. I'm barking up the right tree, if you would. So what can we do next? Well, 1 minus cosine that is sine squared. So a sine will go away with a sine, and 1 over, so we basically have 1 plus cosine squared theta, right, on the top, all over sine theta. Of course, 1 over sine is cosecant of theta times the 1 plus cosine squared theta. And we got it. So we were able to eventually, after finding common denominator, multiplying the bottom as the difference of squares, doing all the multiplication and subtraction upstairs, doing some simplification, and continuing to simplify. Factoring came into play. Right, we were finally able to get the other side. So we've proven that this crazy side is equal to that product over on that side, and we're all set and ready to go and off to the next problem. Okay, so in the next one, I actually have a fraction equal to a fraction. So either side is kind of bad to work with. So how about, since I have a fraction equal to a fraction, why don't I work on both sides at the same time, and I'll use an old trick. I will cross multiply. So we end up with cotangent of x plus 1 times 1 minus the tangent of x. And on the other side, we have 1 plus the tangent of x, cotangent of x minus 1. And so all that's left to do is to hammer this out, right? Foil this out and foil that out. And what we're hoping is we get something equal to something. And if we do, that means this is an identity. If we don't, that means the identity is not proven. So if we FOIL this out, we get a cotangent of x minus a cotangent times tangent plus 1 minus a tangent. Right? So that's that side. On the other side, we get a minus 1. Right? So let me make sure I did that right. Yep. And then plus cotangent of x, tangent of x. We got a cotangent of x, and then we have a tangent of x. Alright, and so that's what we end up, I think that's a plus sign there. Let me write that better. That's cotangent of x. So going through this, cotangent and tangent are basically reciprocals. So this side's the cotangent of x minus 1 plus 1 minus the tangent of x. And again, cotangent tangent is 1, so we got minus 1 plus 1 plus cotangent of x minus tangent of x. The minus 1 and the plus 1 go away. So this side is cotangent minus tangent. Same thing over here, they go away. And we end up with cotangent minus tangent. And I don't know about you, but those sides now look like they're equal. So that tells me that that ratio, or that proportion, is actually equal to each other. So we essentially have a common, we verified that particular identity. So there you go. So a lot of algebra, adding fractions, finding LCDs, combining like terms, factoring, foiling, all right, all that stuff coming into play to verify and / prove identities. Those are my three. I have several videos also showing you other individuals that I found on the internet doing pretty much the same thing, same ideas, different problems. But of course, the best way to get better at this is to do them yourself. Right? Get in there, dive in, try something. If it just doesn't seem to be going well, which is going to happen a lot to you guys, it's okay to start over or maybe ask for some help. All right? That's how you guys are all going to get better at simplifying, rewriting, or in this case, proving and verifying identities. So that wraps up 5.2. Come see me if you need help. Ask your questions on Canvas. Show us your ideas. Compare your ideas with your classmates. Shoot me with an email. Whatever it takes for you guys to keep learning. I'll talk to you guys later.